Hello, in this video we will be introducing the OSQ flow amplifier and its use with EHI and OSPE. Larger machines need more oil flow to be able to steer. The OSQ is a flow amplifier that can be used with an EHI or OSPE on vehicles that require a steering flow of up to 400 liters per minute. Here are some example applications of the OSQ, as these machines require a large steering flow. The OSQ multiplies the flow rate of a pilot steering unit. For example, an orbital or EH valve. The flow from the OSP and from the OSQ is metered into the steering cylinder. The displacement of the steering system with a traditional steering unit, such as OSPBX, and an OSQ, is calculated by multiplying the displacement of the steering unit by the amplification factor of the OSQ. For example, if an OSPBX has the displacement of 400 cubic centimeters per revolution, and the OSQ increases that by a factor of 5, then the displacement of the OSQ steering system will be 2,000 cubic centimeters per revolution. When possible, it is preferred to use a smaller steering unit and an OSQ with a larger amplification factor to help reduce cab noise and save cost by using smaller pilot steering units. If we are using an EHI with a 20 liter per minute EH spool and have an OSQ with an amplification factor of 10, then the max flow of the system will be 200 liters per minute. The max flow of the OSQ is 400 liters per minute. This means that if we have an EHI with a 40 liter per minute EH spool, the amplification factor should not be over 10. When using OSQ, the priority valve, relief valve, and shock valves will be included in the OSQ. Sometimes the steering unit will be required to contain relief or shock valves. In this case, they can be set at maximum values. The amplification spool size is what determines the amplification factor of the OSQ. When using an OSQ, the OSPBX steering unit must be used. When steering, pressure will build in the R line and shift the main spool of the OSQB to the left. This will then allow flow to enter the amplification spool, which will provide an amplified oil flow to the steering cylinder. When the steering unit spool returns to neutral, pressure can get trapped in the R or L line so that the OSQ is still steering. This can cause the steered wheels to drift. The OSPBX steering unit solves this problem by connecting L and R in the spool sleeve set and draining to tank when the spool is in its neutral position. This balances the pressure in L and R so that the OSQ will stop steering. The X in OSPBX denotes this. The OSPE and EHI do not have the X types available. Instead, the trap pressure problem can be addressed by adding external check valves, so oil can flow from the L or R line to the LS line. When steering, the pressure in the LS line will match the steering pressure required, but when the spool is in neutral position, the LS line will be connected to the tank, so the L and R line can drain. One thing to look out for is that back pressure in the OSQ tank line can cause the L and R line not to drain while in neutral. So the EHI or OSPE tank line should be connected directly to the tank, as opposed to the T-port of the flow amplifier. When using an OSQ, OSP, and EHI with external check valves, the OSPBX steering unit is not necessary, as the external check valves provide a way to relieve the pressure in the L or R line. The OSPBX can be used when adding an EHI to a system with an OSQ and an OSPBX. However, in a new system, it is ideal to have a non-reaction unit, so that less parts are needed in the EHI. For example, with a non-reaction OSP, the RSV is no longer needed and the shock valves can be removed from the EHI as well. That is everything for this video. Thank you for watching.